Okay, it's time to review some trig. You'll need lots of trig in calculus as well. And hopefully you remember that great saying called SOHCAHTOA, which stands for, of course, once again, sine of an angle theta is equal to the length of the opposite side divided by the hypotenuse. Cosine of the angle theta, length of the adjacent side divided by the hypotenuse, and tangent theta equaling the length of the opposite side divided by the length of the adjacent side. And then hopefully you learn these reciprocal trig ratios, cosecant, right, CSC, secant, SEC, and cotangent, they're just 1/overs. And yeah, when you're using right angle trig, usually they're measured in degrees, but you'll find out later on why radians are so important. But in the meantime, look at example number 1. If I gave you this lovely triangle, notice I've told you that we're looking at this angle here. So can you find out the ratios here for me, please? My first thing that I would always do is, yes, label the size. The longest, that's right, the hypotenuse. The opposite side, of course, is the one that's across from the angle. So if I look across the angle here, that's this one. This is the opposite side. And the adjacent, of course, is the one next to the angle. So I've labeled my sides. I'm ready to go. Sine theta, then, is opposite over hypotenuse, 4/5. Cosine theta, adjacent over hypotenuse, 3/5. Tangent theta, 4/3, or 4/3. Secant theta, secant is the same thing as, once again, 1/cosine. Cosine is 3/5, so 1/cosine is just 5/3. Cool. That was like way back, right? And then we did more trig stuff. We said, hey, we can define angles with trig more than 90 degrees, but then we had to introduce to you this thing called the unit circle, perhaps, and we're looking at angles being created from an initial arm and a terminal arm, or initial side and terminal side. Hopefully you remember all this stuff here. And then we would rotate it clockwise, which would be negative, counterclockwise, which would be positive. So all this stuff I hope you remember. Then I think we talked about this idea of one rotation of 360 degrees, and that's equivalent to 2 pi radians. Okay, so all this stuff will come into play in AP Calculus, so you need to know this as well. And then we kind of modified our trig expressions. We're not talking about opposite and hypotenuse anymore. We're going to use the y coordinate on this circle with r, which stands for the radius. So sine was now defined as y/r. Looking at this diagram here, that'll help you out. Cosine is defined as x/r, right? If this is the angle theta here, this is x, then tangent, and then cosecant, secant, cotangent, once again the reciprocal. Notice that theta can now be any measure in the circle from 0 to 360 or 0 to 2 pi. R is always just using Pythagoras. It's the square root of x squared plus y squared. And then once again, hey, x, y could be positive, negative, or 0. All right, so hopefully this is not new to you. But if I ask you now in example number 2 to actually figure out these ratios, and this angle is in standard position, I always like to draw it out first. When I see standard position, here's my x, y coordinate axes. -5, 1, 2, 3, 4, 5, and then +2, 1, 2. So your terminal arm is right here. You're thinking, there's my angle. How do I define this once again? Sine is defined as y/r. Now, what's all these variables? What's y? So what's r? In this case, y is 2. In this case, x is -5. And what's r? Oh, I don't know. But you can figure it out. Good old Pythagoras. I think I got here root 29. And since you have all this, you can now go ahead and just quickly write down the ratios. Sine is y/r. Cosecant, ooh, what's that? Well, that's the same thing as 1/sine, so you just want to flip. Cotangent is 1/tangent, or you can say it's not y/x, but x/y, so the x value is -5. the y value is 2. And there you go. Okay. Remember in calculus or in pre-calculus, we made you memorize some special angles or reference angles in triangles. Why is that the case once again? Well, those have nice ratios that you should know. Do you remember how you got those? I'll quickly show you if you're not too sure. 30, 60, 90 came from taking an equilateral triangle with side length 2 and splitting it in half. Chop, chop. So if we're looking just at the 1/2 of it, notice this is 2. This angle down here is 60. We now have a right angle, and this one cut in half becomes 30. Looking at the base here, it used to be 2, so we cut in half, that's 1. And then using Pythagoras, we can find that the height is √3. So that's where that comes from. The other one, the 45, 45, 90, that comes from taking a square. And let's chop that in half. Chop, chop, chop. And so if I chop that in half, I get this lovely triangle. Let me just draw it here for you. 45 degrees, 45 degrees, 90 degrees, and if I had a side length of 1, then I get 1, 1, √2. So you can visualize, memorize, whatever you want, but you do need to know these nice special angles. And how does that help us out? Well, hopefully you can see that cosine 210, if I were to draw where 210 degrees is on the coordinate axis plane, 210 degrees, that's what, starting here, 0, 210 probably is right over here, and that would be 210. It's helpful because remember that idea of the reference angle, that would be the angle from the terminal arm to the positive or negative side of the x-axis, that equals to just 30 degrees. And that's helpful because look, I now have a lovely triangle that looks very similar to a 30, 60, 90 triangle. Good. And then visually, hopefully you can see that the sides are 1, 2, and √3, but be careful because you are in the third quadrant. Notice your x and your y's have to be negative. And once you've drawn this out, I hope you can now tell me what the cosine 210 degree ratio is equal to. The cosine ratio is defined as x over r. In this case, x is negative √3. R is the radius. Done. Okay. So can you quickly try B on your own, please? And then double check your answer with mine. Go! Find the reference angle. Draw your triangle. Make sure you put negatives where it's supposed to be negative. And tangent is defined as y over x. So y over x, that's right. The answer is just -1. Cool. I hope you remember how to also convert radians to degrees and all that. The key thing is noticing pi radians equals to 180 degrees. So if you like to use conversion factors, you hopefully remember that you can multiply by pi over 180, and this is to go from degrees to radians, multiply, and then vice versa from radians to degrees, you multiply by 180 over pi. So whatever works for you, but hopefully you can see this. What's pi over 2 now in terms of degrees? If I were to use the conversion factor, I just multiply this by 180 over pi. You might already know this. That's just 180 over 2. That's 90. Pi over 2 is 90 degrees. Since once again, you could have just done this. Pi is 180. Divide that by 2, right? So hopefully you can see these. But pi over 4, I'm just going to tell you, is 45. Pi over 3 is 60. And pi over 6 is 30. So you should memorize these. They're quite commonly used. Similarly, converting from radians to degrees or degrees to radians without the calculator, once again, we can use these conversion factors. So 5 pi over 4. I will just quickly say this. Oops, I need a pen. 5 pi over 4. I'm going to multiply that by 180 over pi. And then you can figure this out. I think that would be 225 degrees. 270 degrees. In this case, I'll multiply by pi over 180 degrees, and that gives you, I think, 3 pi over 2 radians. You can put a little r here if you want, but if you don't put an r, we always assume now that the angle is always in radians. And similarly, negatives, don't freak out, same idea. I think you get negative 2 pi over 3. Okay? So now, I want to practice the same thing as example number 3, but this time our examples are all in radians. Okay, so once again, practice drawing them out, please. And then going from there. So 5 pi over 6. I'm visualizing that, and that's in quadrant number 2. That's 5 pi over 6. My reference angle here must be then, the whole thing is pi, so you could do it as pi minus 5 pi over 6. And that's, of course, 6 pi over 6 minus 5 pi over 6. That's just pi over 6. Or a little trick is just looking at the denominator. It's over 6, so hey, it must be pi over 6. Knowing that this is pi over 6, I can now draw my triangle and then label the sides 1, 2, root 3, making sure that because this is in quadrant 2, I need the x value also to be negative. So therefore, what is tangent 5 pi over 6? Tangent is defined as y over x. Done. Okay. Let me quickly do 7 for you, and I want you to try 8 on your own. But for 7, cosine negative 3 pi over 4, once again, if I'm drawing the angle, because it's negative, I'm now going to sweep clockwise. So here we go. There is my negative 3 pi over 4. I still need to find the reference angle, and hopefully you can visualize this reference angle being, that's right, pi over 4. And then now I draw my lovely triangle, label the sides 1, 1, root 2, double check which one's negative. That's right, it's in quadrant 3, so the y value must be negative. And so now I can find cosine. Oops, don't forget the x is also negative. Woo! I'm glad I caught myself. And then the cosine ratio is just negative 1 over root 2. Beautiful. Okay, this one is yours. Have fun. 5 pi over 3. Where is 5 pi over 3? Ding. In the 4th quadrant. Good. Which means my reference angle here is pi over 3. Okay. 1, 2, negative root 3. Good. Cosecant, you can define it as the same thing as 1 over sine of 5 pi over 3 if you want. Sine of 5 pi over 3, that's sine is defined as y over r, so that's 1 over y would be negative root 3 over r. Or better yet, then the flip of that would just be 2 over negative root 3. Now you didn't actually need to do it this way. You could have just said cosecant 5 pi over 3 is defined as r over y. That's fine, you could have done that. But I wanted you to see that this is equal to 1 over, and you're taking the sign of the ratio. A lot of students commonly then do some weird stuff like this. They flip the 3 and over 5 pi. Please don't do that, okay? It's 1 over the entire expression of sine of the angle, not flipping the angle. Okay, good. Moving on. More review of trig. Yes, then we talk about the unit circle. And then now, instead of having r being any value, we can now limit it to being equal to 1. And that simplifies our functions quite a bit because the sine theta value is just now y over 1, or y over 1, of course, is just y. Cosine theta is just x over 1, or just x. No change for tangent, though. Okay? So now knowing this, we should be able to find these particular values for a unit circle. And I hope you can visualize these. I'm just going to quickly show you these special ones, or what they call quadrantal. Notice at this point here, this is the coordinate 1, 0. At pi over 2, the coordinate is 0, 1. Notice over here at pi, it's negative 1 comma 0. And then at 3 pi over 2, it's 0 comma negative 1. Okay? So I'm hoping that you can now use this circle and figure out these values. Okay? I want you to try yourself. Sine pi over 6, you should know that. That's 1/2. Sine of 0 in this case, looking at the angle of 0, you're on the positive y-axis. The sine is the y value, that's just 0. Cosine of 0, once again, this 0 represents the angle, so you're looking right here on the x-axis. The cosine value must be the x value, it's 1. Okay? Go ahead, please, and try the rest on your own, and double check your answers with me when you're done. Press pause. Ooh, J is kind of weird. Negative pi, what's that? Starting here, whoop, going like that, that's negative pi. So negative pi is equivalent to actually pi, so this is the same thing as cosine of pi, and the cosine of pi is just negative 1. Tangent negative pi over 2, that's interesting. That's going this way, that's down here. Tangent, of course, is y over x, so negative 1 over 0. What's that? Yes, it's undefined. Okay, so as you can see from example 9, the unit circle was very useful when finding trig ratios for quadrant separators, meaning on the actual x or y axis, since, of course, there are no reference triangles there. Okay? Hopefully you know this as well. These are what they call the quotient identities. Tangent is defined as sine over cos, and then cotangent is defined as cos over sine. Those are all helpful, because pretty much everything can be brought down to just sine and cosine. So if I ask you for number 10 here, it says, if sine theta equals to 3/5, find all the possible values. Knowing that sine equals to 3/5, can you visualize what that looks like here? So that means if I draw a triangle, I have here 3, 5, and then I guess 4. Now my question is this the only triangle that you can create to represent sine theta equals to 3/5? I hope you are saying no, 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 because I could have also drawn my angle or my triangle here. This is still 3, right? The y value is still positive 3. The radius is still positive 5, but this time notice here the x value is negative 4. And if you couldn't see how I got that, you could have just used Pythagoras. Remember, I have here x squared plus the y squared equals to 5 squared, and then you could have, sorry, not 5 squared, 5. You could have then squared both sides, solve, and then don't forget x equals to plus or minus 4, and that's why you get 2 pictures. So therefore, what is cosecant here? Well, cosecant is the same thing as 1 over sine, no problem there, that's just 5 over 3. But for cosine now, please, because you see there's 2 possible values of x, this could be 4/5 or negative 4/5. We actually cannot tell. And same thing for tangent right now, since it's y over x, it could be 3 over 4 or negative 3 over 4. I cannot tell. Okay? If I gave you some more information, then I can eliminate one of those values, but right now I can't, and that's why the question said find the possible values for these expressions. Okay, last but not least, solving trig equations without a calculator. Oh no, no calculator required. Yes, so that's why you need to know those special angles. I look at A and I think, ew, cosecant, yuck, 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 yuck. Can we change it to one of the ones we like, sine, cosine, or tangent? You bet. I can change that into sine x, which equals to root 3 over 2 negatively. And if you think about that, how do I solve? You have to do the inverse sign. And remember, we have no calculator right now, so you got to think to yourself, what angle gives me this ratio, root 3 over 2? Negative. I can visualize, and I hope you can too, Sine is defined as y over r. Really, I should be rewriting this because if the r value is 2, I should write the negative with the root 3. So, y value, oh, here's one way. Negative root 3, 2, and therefore this must be 1. So therefore, my question is, what is this angle measurement equal to? We know that this is a 30, 60, 90 triangle. This, and because our answers are in radians, I should write as pi over 3. So one of our answers here, x equals to 2 pi, which is the full rotation, minus that pi over 3, that would be 5 pi over 3. Ding! That works. If you leave it as one answer, that doesn't work, because there is another picture that we can draw. Yes, there is another one, and I'll draw it up here, because I can also have the triangle in the third quadrant. Negative 1, negative root 3, and then also 2. In this case, this angle here is also going to be pi over 3 as my reference angle. And so now if I want to actually figure out the actual angle, the other x here would be pi plus pi over 3, or 4 pi over 3. So two answers, 5 pi over 3, 4 pi over 3. Done. Okay. I'm hoping that you can try B, but if you need help, then keep listening to me. If you don't, then I want you to try it yourself first, then come back and once again check. It's always better if you can do it first and then come back and check. Cotangent. Let me rewrite that as tangent. And that means it's the reciprocal, 1 over root 3. Time to draw my pictures. My first one, tangent, 1 over root 3. Y over x. Y, x. That must be 2. Therefore, my reference angle here must be pi over 6. And therefore, because this is already in that right position, I'll say theta equals to pi over 6. Ding! Okay. Oh, wait. Where else can I have this? Where else is tangent positive? Oh, yeah, you can think it's in quadrant 3, because notice now, this is negative 1. This is also negative root 3. So the two negatives in the ratio divided by each other become positive. So this also works. Here's my reference angle. My question for all of us is, what is the actual angle? That would be pi plus pi over 6, or 7 pi over 6. Did you get that? Great. Give yourself a pat on the back. And now finally for 2c. Ooh, squared. Yuck. Don't worry. Same thing. We'll move the 1 to the right-hand side. We'll divide everything by 2. We'll square root both sides, and once again, please, 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 plus or minus. And so ultimately, here, you actually have 2 separate equations. Or, okay, and by the way, I kind of glossed over that, but cosine squared is the same thing as cosine theta all squared. So if you didn't really understand what I did there, I could have done it like this. Now I'm going to square root both sides, and notice, okay, plus minus. And so now ultimately you have 2 things to solve, and I'm going to ask you to try that yourself. I'm predicting there will be 2 answers from the positive 1 over square root 2 equation, and also an additional 2 from the negative. And I want you to try that, and then you come back. I'm not going to show you this one, but I will tell you the answers in the end. Okay? So 4 different answers. Please, 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 please be very careful with your signs. They make a difference. Okay? This is just part 1 review of trig. Our next lesson is also more trig. So make sure you do some of the questions here, get good at it before you move on to lesson number 0.5. See you then.